Hey, John Catalano here from Diamond Audio, and on today's workshop, we're going to be showing you how to set up your new Neo DSP amplifier. So the key to making great sound quality is setting up the amplifier properly. So we're going to be looking at matching our input signal to our output, adjusting it so it matches our speakers, and then from there, we can start doing tuning and time alignment where needed. So, but first and foremost, if we don't get the input signal matched to the amplifier, we're starting off on the wrong foot. So we're going to make sure we have no distortion and everything is perfectly clean. So step one is going to be, you're going to select your source. So we can come over here in our PC interface and we can hit this drop down and we can select analog or Bluetooth. In this case, just for sake of setting up, we're going to use Bluetooth. So I'm going to click Bluetooth, and then that's going to be our signal source. So for this step, we're going to go to our website, diamondaudio.com. We're going to select our Neo DSP amplifiers, and we can select any of the amps. It really doesn't matter for this step. You're just going to pick one, and then we're going to scroll down on the website to our power chart. And what we're going to use this for is we're going to match what our output power needs to be to our speakers. So we're going to set up the amp for whichever is less. So if let's say our speakers are 300 watts, they can handle 300 watts RMS, and our amplifier is going to be producing 250 watts, well, we're going to set up the amplifier for 250. If the speaker is only good for 150 watts, we would set up the amplifier for 150 watts instead of the 250. If you can follow me. That way, we know we can play full volume without distortion and not have any failures from our speakers or our amplifiers. We're not having distortion coming out of the amplifier, and we're not having distortion out of our speakers. So in this case, I have on our bench today the Neo 1506 DSP. So it is rated at 150 watts at 4 ohms or 250 watts at 2 ohms. We're going to set it up for 150 watts. Doesn't really matter. The numbers would work out to be the same, but we'll go ahead and put our 150 watts into our website. And then it's going to give us our target voltage at 4 ohms is 24.49 volts. So we're going to try to get as close to that as possible while we're setting up our DSP. So then we'll go back to our DSP software. We're going to put a 1K test tone on our phone, and we're going to put the phone all the way up, and then we're going to adjust our level here on our screen. This is going to be our input level, and then on our oscilloscope, we're going to look and we're going to try to get our RMS power to as close to 24.4 volt or 24.49 volts or 24.5 volts as we can. And I'm slowly turning it up. And I went a little hot here so that I can back it down. And as you can see, even at 26 volts, we don't have any distortion. Once we pass that, we start getting distortion. So the amplifier will produce more than the 150 that we rated at, but we want to put it at our 24.5. So using my cursor, or I should my keys, I can get it, it'll jump in 1 dB increments, but I'm going to have to type it in here to get closer. So I'm going to go to 13.2. Still not enough. We want to go up a little more. And there we have it, our 24.45. You know, it fluctuates a little bit. We're right there on the money. So now we know that our amplifier is going to produce 150 watts to our 4 ohm driver on all channels. We've now matched our level input to the output of the amp, and now we never have to touch that again. All right, so now that we've set our input level, we know that the amplifier can produce our proper output with our input signal. Now, if we need to adjust the output, let's say you got tweeters on the front channels and mids on the second pair of channels, well, you're not going to need 150 watts going to the tweeters when there's only 150 watts going to the mid-range. You're going to, explode the tweeters or your ears in the process. So here we can adjust the individual level of each channel. So we can scroll these up or down. And there's also a secondary place we could do that, which is in the mixer. So I'll click that. And in here, the mixer does two things. Let's say we only had 2 channels of input. We could still drive all 8 channels of the DSP with that. We would just tell it that we want to drive our signal from channels 1 and 2 on Bluetooth. And then we would select that for all of our channels, right? So we can go channel 2. So now for channel 1, we're getting our signal from the left channel, and channel 2, we're getting our signal from Bluetooth right channel. And then we can go on and select this for all the channels, so all the channels would get that same signal. And then from here, we can even adjust the output level too. We can adjust it here or from the master on the other screen. I personally like to do it here. You can do some fun things. Let's say you wanted to make a center channel. You would drive your signal from channel 1 and 2 on that. And then you can adjust this to like 50% from the left channel and 50% from the right channel. And now that could be a center channel, right? So now you're monoing that signal. So it's very, very flexible. You can do a lot of stuff in this panel. All right, so now we're going to tune the DSP. Like, first thing we would do when we're going to do the DSP is we're going to set our crossover points. We have some presets built in. So on your front left, right, where you could say it's like a tweeter, it would go ahead and throw, I'm going to link these channels. If we went ahead and select this to be our tweeter or mid-range, we can go front, left, tweeter, front right, tweeter, and then we can link these. And then wherever we set our crossover point, let's say we want to do 24 dB on that. And then we're going to change our high pass to 5K. And then if we wanted to roll this off for some reason, we could, we can put like a 20K high pass on there or low pass on there, just so it, you're not driving it with things that we don't want. We can add our, excuse me, we can add our, what kind of, we want Bessel, Butterworth, or Linkwitz-Riley. Our dBs here, so we can see we have a small adjustment there when we add that roll off there, right? So you can do 42, 48. So you get it's just kind of like a little protection for your tweeters. You don't need to really be playing over 20K. You can't hear that anyway. Then from there, once you've set your crossovers, and then you would set this for, whatever you're going to do for each pair of channels. Then we can go into our extra options. So here we have our noise gate, which is a nice feature. So let's say you have a little bit of noise floor from your factory, like you're using a factory radio or something, and you got a little bit of noise floor. You can go ahead and go in here and slightly adjust this. And what it'll do is it's going to mute that channel until it sees audio on the signal. So once the audio comes in, it'll unmute it so you don't hear like the noise floor, like a static or anything like that coming from that OEM setup. You can adjust your Bluetooth input volume here if you needed to. Really, you don't have to. We can go ahead and just turn it all the way up and then adjust it with the other one, but it does give you another option here. We also have auto turn off. So if you have multiple amplifiers and maybe you have a turn off pop, you can adjust this delay so it's a little bit slower so you don't get that. You could also do power on and off. So if you have something, again, this is more for the OEM integration. You get like little clicks and pops and things when you're trying to integrate with these factory systems. These options give you ways around that so you have a noise-free system. You can delay your amplifiers so they turn on in sequence. You can delay them on and off. All these things help you make sure that your signal is perfectly clean. And then once you've set all that up, if you're doing it in a, let's say, a car, you would measure from the listening position, the person sitting in the listening position, you measure from the ear to each speaker. You're going to add those two measurements together, and then you're going to subtract the lesser of the two, and then the difference you're going to add into the area where we have our alignment. So here, let's say the tweeter was, I like to do it in millimeters or centimeters. So let's say the tweeter on the left side was 100 millimeters or centimeters from the listener, and the tweeter on the right-hand side is 200, just for argument's sake. So what we could do is we could add delay here. We could add 100 centimeters of delay. That's the closest we're going to get, 100 centimeters of delay, right? So that way, and we're going to have no delay on the left, and we're going to have 100 centimeters of delay. I'm sorry, I did that backwards. We need to have 100 centimeters of delay on the left side and no delay on the right side. And that allows the sound from those tweeters to reach the listener at the same time. And then we would do that subsequently for the woofer or the mid-range. However, all that is, you're going to go ahead and delay those so they all reach the listener at the same time. This is going to optimize your sound quality and your sound stage. And then the final step is we're going to go in and we're going to adjust any equalization. Hopefully you have an RTA. You can set up your RTA, and then you can adjust the equalization to get the sound the way that you want. You can start with a flat signal and then adjust from there. But all of these are fully adjustable. Not only can you add boost and cut, I recommend that you do cuts, not boost. But a little boost is okay, but I wouldn't do anything more than maybe 6 dB. And then you can also adjust your frequency here. They're fully adjustable, left and right. You can also adjust how wide it goes. So as you can see, if I'm just going to, for sake of argument, if I boosted this, I can make it very, very narrow, or I can make it very wide where that adjustment is being applied. And then we can move it left and right. So if you have an RTA while you're doing this, you can see real time what's happening to the signal path. Makes it infinitely adjustable. You can get rid of just about any anomaly you might have in that vehicle from reflections or some crossover points that may be coming through from an OEM system. But if you want to tune your system, you can spend hours doing this to dial it in perfectly. Well, I thank you for tuning in for this workshop. I didn't go into every possible detail. There's so much more that you can learn about setting up a DSP. This is like a quick overview. Please, for more specs, how-to videos, visit us at diamondaudio.com, where there's plenty of information on how to tune your DSP. You can always contact our tech support as well. We have an excellent tech support team. So please, look forward to seeing you on the next one.